Welcome to Citywide Inclusive Sanitation, Service Assessment and Planning CWIS SAP Tool training video. In the part 1, we had seen how to access and log into the tool. In this video, we will cover how to use the tool. As we sign in using the ID and the password created for us, we land on the city management page. We have a pre-filled city, the Sim city, for this demo purpose. In this city tile, you can see the population of the city is 350,000, and of which the 30% of the households live in the low income households and the rest 70% on the non-low income households. We can also see when it was last updated and who updated it. Let's start filling the city details using the drop-down menu here. We use this place to describe the profile of the city or the service planning area. The city name is a unique name provided for this dashboard. When we replicate the city using the duplicate city feature, the data of the city as we enter gets completely copied with its name, title, and this title called city name underscore copy. Each city can be copied as many number of times, and we may have to rename from the default name copied. The city can be copied any number of times, and we may have to rename from the default name when copied. The tool provides you the freedom to choose any currency of valuation. The population of the city or the service area for which we are assessing. This can be from a recently published report and can be adjusted or matched for the year in which our assessment starts. The population growth rate is the rate at which the population grows for a service area. Inflation rate is the average projected growth rate in the prices of goods and services in the service area. The tool projects the plan for a 10-year period. We can choose a baseline year from which we want assessment for comparing with the target year by which we want to reach our goals. The target year can be any year within the 10-year projection period. We may have to note that other than the baseline, the sanitation coverage we entered will be considered as the target year's coverage. The average household size is the closest integer representing the number of people sharing a household. Here, we fill in the percentage of the low-income households and the non-low-income households as a percentage of the total population. The low-income and the non-low-income households can be filled based on the estimates of the income or a designated household areas, etc. This is specific for the country or the surface area. The affordability benchmark is the annual median disposable income that can be spent on sanitation. Here, it is just for internal reference to guide tariff changes and is optional. Once we complete, we can have a quick check and press the submit button at the right bottom of the page. Now we go back to the city management page. In the city tile, we start by selecting edit scenarios in the drop down. This takes us to the input session. When creating and entering the input for the first time, we will be shown only the baseline button. Our entries are going to be under this tab, and as we keep adding scenarios, we would be having a horizontal scroll here. We can add scenarios by using this button, add scenario. This will copy the baseline and fill the data for 10 years. Scenarios are the user-defined changes from the baseline to achieve a particular target in the target year. The scenarios are stacked in a horizontal scroll as we create them. It is important to have a check if we are entering data under the baseline or the scenarios. There are a couple of features, namely the edit scenarios that allows the user to choose the scenario that they have previously filled in and change the name and the description. There is also option to delete or restore the scenarios that you may not want. The notes section allows the user to define and document their assumptions or explanation for each section under the selected scenario. There is also a data tab all along for guiding the data columns. The main parameters of the city are displayed on the top. The left navigation bar takes us to the respective section under the scenario. As we see, it moves from entering the coverage to defining the service model and the service delivery chain. At every page, there are buttons like Next, Previous, and Cancel in the right bottom. Once the data is filled in a section, we may want to press Next to store the data entered. Let's start at Define Sanitation System. We define how the coverage of the city is mapped along the value chain from toilets to reuse. In toilet section, we have cistern flush, port flush, and slab toilets available in the city. The water per person use data are filled in. The containment or the connection section allows the user to enter the percentage of population having a particular category such as conventional sewer, non-conventional sewer, safe on-site and unsafe on-site. They can be further bifurcated in two individual types. If a specific typology of your city is not available in the list, one can choose the closest representation. Example, if there are only twin pit latrines in your city, they can be entered as line pits. Also, if there are no simplified sewers in your city, the entry can be kept 0 and subsequent entries in the following sections need not be made. These can be added in the scenarios if it is planned later on as an investment. The total percentage population filled under the low income households and the non-low income households cannot exceed the number under its respective category in the edit city details. However, the total can be lesser than the actual, which indicates that these may be considered as unknown containments. When we move to the emptying and transportation, we have three types of emptying hardware, namely the vacuum truck, manual emptying with MDUs, that is mechanical desludging units, and manual emptying with buckets and shovels. Here we enter the percentage emptied from each type of the containment by a specific type of hardware. We have to keep filling the serviced columns across the different types of emptying hardware, and the unserviced gets totaled and automatically computed. This is where the percentage of the fecal sludge emptied from the manual emptying is being transported is filled in. In case the emptied sludge is dumped elsewhere, the value can be entered as 0. We then move to the treatment where to what extent the emptied sludge is being deposited either in a wastewater treatment plant or the fecal sludge treatment plant is entered here. Please note that it is up to the user to define if the WWTP can take. Lastly, if the treated fecal sludge is being reused, this is where you need to enter the data. So far, we have successfully defined the baseline with respect to what type of containment systems are prevalent and how each system is being served along the sanitation chain. Going further, who provides the service is added in the service delivery model. This also flows from the containment to reuse. We have options to choose such as utility providing the service or the O&M contract with the private sector, or in terms of the containment, the household themselves building the containment or households builds with the utility financing. We also see who provides a service in the emptying and transportation, namely the utility provides a service predominantly, or the regulated private sector, unregulated private sector, or it is coexisting between the three. Mapping this allows the user to define who provides the service and also later in the tool the respective number of hardware, its capex, opex, and the charges providing the service. Now we move on and provide details for different segments of the value chain from containment through reuse. In each category, we have the same sections, namely the hardware details, the demand details, the capex, opex, and the source of finance. You can add decimal values in most of the section barring a few where an error message saying that please enter valid data would appear. For the conventional sewer, in the hardware details, the total number of units, say the length of the network, the number of pumping stations, the cannon jets, and the average number of connections per typology is filled in. We may want to note that this data must relate to the coverage entered in the defined sanitation system. While you have to enter the baseline data, for other scenarios, the hardware data for the 10-year period will be automatically copied for a 10-year period, and this can be modified in a specific year as you deem fit. Next is the demand section where you need to enter information about the price or the tariff charged. In this section, we have multiple tariff models based on the connection typology. For example, we have the volumetric sanitation tariff, the sanitation tariff as a proportion of water bill, and flat sanitation fee. We also have provision for sanitation levy as a percentage or as a flat amount. The predominant type of tariff is selected here. This can be modified if it changes in the scenarios from the baseline. Any other additional annual revenue from non-volumetric sources can be added here. The inflation rate is automatically filled in from our entry in the city detail page. However, if a different rate and frequency of change is applicable, it can be modified by changing the inflation rate and the frequency. Please note that this entry will be applicable only for this section. The capex is calculated as cost per unit and is used in computing the capital expenditure of the planned investment as we enter the additional hardware in this above section under a particular year. The useful life of the hardware is also entered here. In case of the containment or connection, there are options for selecting financed by households or the utility. Depending upon the selection in the defined service delivery, under the utility financing, we enter the proportion of connections financed by the utility and also the percentage of cost borne by this utility. The proportion finance is what proportion of the additional or the new units that are added in a particular year is planned to be financed by the utility. For example, it can be commensurate to finance only the line pit latrines used predominantly by the low-income households. Extraordinary repairs are one-time capital expenditure to be incurred in the 10-year projection period. The cost, the useful life, and the year of extraordinary repair is also described here. The existing depreciation and the interest liability captures the book depreciation and the interest rate that are currently ongoing. This existing depreciation and interest rates are also used in computation of the utility financials. The operating expenditure is the cost under each of the operating heads represented as per unit cost. It has both the current and the optimal cost. The optimal cost are the operational expenditure that may be applicable instead of today's current cost during the operating period. We may also fill in the year at which during the optimal cost will kick in. Please note, if there are no optimal costs, the current costs themselves can be filled in and need not be kept as zero. The overheads in the operating cost are also filled as a percentage of the direct cost. In filling both the capex and opex in each section, we can provide either a detailed breakdown of the cost as the line items provided here, or group it under a single head and in case of an estimate and collect it and expand it subsequently. In the source of finance, we can add different funding available or planned. The source of finance can be either grants, equity, loans, or own funds by themselves. These funds can cover both the capex and opex. In case the source of finance is not clearly identified at this stage, it can be revisited at a later stage. Similarly, as we move towards the hardware section under the emptying and transportation category, the tool allows you to enter the data only in the shortlisted sections based on the selection of the service model. In case of a proposed scenario where you may want to change the service delivery model, say from here the unregulated to regulated and utility as well, make sure that the respective hardware numbers are also updated. We go ahead and fill the sections on the treatment and reuse. At the right bottom corner of the reuse section is the compute button, which allows the user to start the calculation of the data entered. At any point, if we change the data, we might want to go to the edit scenario, change the data and go to the reuse section and press compute. When replicating from the baseline to any scenario, we may want to keep a note of the following things. Change the coverage in the defined sanitation system. Modify for any service delivery model changes. Update the number of the hardware corresponding to the changed coverage entered in the defined sanitation system. Also, update the total number of units in the hardware detail section for the safe containment corresponding to an yearly coverage. Add new inputs into the hardware corresponding to any changes in the service delivery model, especially in the ENT section. We have come to the end of part 2 of the CWIS SAP training video. Thank you.